lecture series of mathematical modeling of manufacturing processes with subject code KME 073. It is an department elective subject and I am Dr. Suman Gotwal, working as an assistant professor in the Department of Mechanical Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. So, in today's lecture, we are going to start about the merchant circles force analysis. As in our last lecture, we started about the different forces that act during the cutting operation, or we can say the mechanics of the orthogonal cutting. Okay. And we saw that when the cutting operation takes place, the different forces act during that operation. And when we started this merchant circle, then some assumptions were made, like this one is based on the minimum energy shear principle, which states that the shear plane is located at a place where the minimum energy is required to deform the material. Okay. So, today we are going to analyze those forces in detail. So, these will be the outline during today's lecture. First, we are going to start about the force analysis, means we will see what are the different forces that act during the cutting operation. Okay. And we will do the derivation for these forces and we will determine the merchant first equation. Okay. So, this is the force analysis. This circle basically known as the merchant circle. Okay. And here we made an assumption that all the forces that are acting during the cutting operation, they are acting at the tip of the tool or towards the tip of the tool instead of their actual point of action. And why are we doing this assumption? So that we can make a circle and all the forces are coming in that circle, and we will analyze this circle now, and the circle is known as the merchant circle. So, first we will go through the different forces that act during the cutting operation. So, as we discussed in our last lecture also, that this is the horizontal force and this horizontal force is known as the cutting force, or we say the horizontal force. And one force which is acting normal to this cutting force is known as the thrust force or the vertical force. We have denoted it with the help of Ft. After that, we know that this is the shear plane along which the shear action is taking place or the material is deforming. So, one force will act along this plane also, and this force is known as the shear force. It is denoted by Fs. After that, one force which is the normal to the shear force is known as the Ns. It is denoted by Ns, and this is the force which is normal to the shear force. And here we can see here the R is mentioned, which is the resultant of the Fc, Ft, and it is also the resultant of the Fc and Ns. Then this is the force F. F is basically the friction force which will act along the rake face of the tool. Okay. And this is the force which is denoted by the N, which is the force which is the normal to this friction force. This angle is known as the shear angle, it is denoted by phi, and this angle is your friction angle, which is denoted by beta. Okay. And this angle is alpha, this one will also be alpha, and in our last lecture we determine this angle which comes out to be beta minus alpha. Now, we will study these forces in detail. So, in our last lecture we did the derivation for Fs and Fn. Fs is your shear force and Fn is basically the force which is normal to the shear force. So, in today's lecture we are going to start the force calculation for the friction force and the force which is normal to the friction force. So, these are the forces which will act during the cutting action. means these 6 forces will act during cutting operation. So, first we can see here F is equal to F t cos alpha plus F c sin alpha and N is equal to F c cos alpha minus F t sin alpha. Now, we will derive it from the merchant circle. So, what we will do? We can see here that 4 forces are involved in these two equations, the force F, N, F t and F c. So, we will take the triangles which are having these 4 forces. So, what we will do here? We will draw the diagram from the merchant circle. So, this one is our F c, this is our F t, okay. Cutting force and the force which is vertical to the which is normal to the cutting force, okay. And this is our R, resultant of these two forces, and after that we can take here okay, this one is your F force and this is our normal to the this F force. This is the friction force, this one is the normal to friction force, and this angle will become beta here, okay. Now, we will this one will become beta minus alpha and this will become, if this is 90, this will become basically 90 minus beta, okay. This is 90 here, this angle is beta and this will become 90 minus beta, okay. Now, if this is point A, this is point B and this is point C. Now, what we will do? We will take one line from A like this, okay, and this point will become F. One line is coming here also, this point is basically D and we will make one perpendicular over this, this will become E, this point will become G, okay. Okay, this will become our phi. Okay, this is our final diagram in which this is the friction force, this one is normal to friction force, this is the resultant for this and this angle is beta minus alpha, this is 90 minus beta, this one is beta and we have made one line and we have extended this line to the F and then we made one line F B and this F B is parallel to D E and then we made a perpendicular over the C and D. Now, what we will do? We want to derive this equation F is equal to F t cos alpha plus F c sin alpha. Okay. So, we will see here what is F? F is equal to A g, okay, or we can write down it A g is parallel to C d, we can write down it like C d. Now, C d is basically C e plus E d, okay, C e plus E d. Now, we know that E d and B f are parallel, so we can replace it. So, it will become C e plus B f, this will become the value of f. So, now what we have to do? We have to find out the value of C e and B f. So, C e की value देखिए, C e is basically this one and B f is this one. So, we will find out the value. So, first we will take the triangle BCE, Okay. In triangle BCE, basically C is equal to f t cos alpha. Okay. C is equal to f t cos alpha, and f t will become C e by cos alpha. Okay. And for this B f, we will take the triangle A B F. So, in triangle A B F, basically the value of sin alpha will be B f by F c. Okay. Sin alpha will become this. So, we can write down B f will become sin alpha into F c. Okay. So, f was C e plus B f, C e की वैल्यू यहाँ से लेंगे, तो f will become f t cos alpha plus B f. B f is f c sin alpha. It is same as this equation. So, in this way we can derive any force from merchant circle. Now, we will do the derivation for force N. So, we will draw the same diagram again. This point is A, this one is B, this one is C. Okay. This was basically D, F, this was E, this was G. Okay. This angle was 90 minus beta, and this one is beta minus alpha. Okay. Now, what we will do? We will find out the N. Okay. We will find out the force N. So, N we can write down is equal to C g, and which can be written as A d. Okay. C g is equal to A d, and A d we can write down as A f minus. Okay. So, we will find out these two value A f and A d. Okay. So, what we will do? We will take the triangle A B F. So, in triangle A B F, the value of the cos alpha will be A f divided by F c, A f divided by F c. So, we can write down the value of A f as F c into cos alpha. Okay. And for this A d, we will take the triangle B C E, and in triangle B C E, what will be the sin alpha? Sin alpha will become basically B e divided by F t. So, we can find out the value of B e as F t sin alpha. Okay. Now, what will become the value of N? N will be A f. A f is F c cos alpha and minus A d. A d is your F t sin alpha, which is same as this one. Okay. Okay. So, these are the forces. Now, as we know that mu is the coefficient of friction, and we can write down mu as the tan beta. Tan beta can be written as F by N, and we have the equation for both F and N. So, F is basically F t cos alpha plus F t sin alpha, and value of N is F c cos alpha minus F t sin alpha. So, we can write down this equation as F t plus F c tan alpha. Okay, we will divide it by cos alpha, so it will become like this, and this F c minus F t tan alpha. We can write down it like this. Now, what we will do? We will see the shear area. Okay, we will see the shear area like this. This will be like this. Okay, we can write down like this. Okay, this is basically our workpiece, and here the tool is acting. Here the tool is acting, and we see that this is the plane along which the shearing action is taking place. So, we can say this is our shear plane. So, force Fs is acting at this plane, and this one is our shear area. Okay. This will become the width B. This will become the angle phi. Phi is our shear angle, and this will become basically the value of T1. T1 is our uncut chip thickness. So, this is our T1 uncut chip thickness. Okay. So, we can write down, if we write down the shear area, okay, this shear area. Shear area basically, shear area will become B into T1, B into T1 by sin phi. Okay. And if we talk about the shear force, तो shear force क्या हो जाएगा? Shear force को लिख सकते हैं Fs, and Fs will become tau into As. Tau is basically our mean shear stress. Okay, tau is our mean shear stress in the shear plane. Okay, tau is our mean. तो tau क्या होता है? Force by area. तो force क्या, shear force क्या हो जाएगा? Tau into As. Okay. तो shear force की वैल्यू क्या आ जाएगी? Fs will become tau, As की वैल्यू पुट कर दीजिए B into T1 by sin phi. This will become our shear force. So, if we have the value of tau, means mean shear stress is given, so we can find out the shear force. Okay. Now, this is the mean shear stress, or if we want to find out the sigma, sigma is basically the normal stress, mean normal stress in the shear plane. तो shear stress क्या हो जाएगा? Sigma s will become Fn by An. Okay, and this Fn will become sigma into B into T1 by sin phi. Okay, ये आपका नॉर्मल फोर्स हो जाएगा Fn. ओके, अगर यहाँ पे बात करें तो शेयर फोर्स, और यहाँ अगर नॉर्मल की बात कर रहे हैं तो force which is normal to the shear force. So, in this way we can find out the value of tau and sigma. Clear? Okay. Now, here till now we have derived 4 forces, that is Fs, Fn, Fs, Fn, F and N. Okay. This force we have already derived. This is shear force, this is normal to the shear force, this one is friction force and this is normal to friction force. Now, our last forces that we want to determine are Fc and Ft. Fc is basically our cutting force and this is our thrust force. So, Fc we can see from the equations that Fc is equal to Fs cos phi plus Fn sin phi and Ft is equal to Fn cos phi minus Fs sin phi. So, what we will do by equation Fn, Fn इक्वेशन को अगर हम पुट कर दें इस इक्वेशन के अंदर तो क्या आ जाएगा हमारे पास, और Fc की वैल्यू क्या है, Fc की वैल्यू क्या हो जाएगी, दिस विल बिकम Fs cos phi ओके एंड Fn sin phi into this will become tan phi plus beta minus alpha. ओके ये वैल्यू पुट कर दी, Fn की जगह ये वाली वैल्यू पुट कर दी हमने, है ना, इसको कॉमन ले लिया. नाउ सिमिलरली वी कैन राइट डाउन द इक्वेशन फॉर Ft ऑल्सो. सो इन केस ऑफ द Ft विल बिकम Fn cos phi into tan phi plus beta minus sin phi. Okay, and by rearranging these two equations, by rearranging these two equations, we will get the values of Fc and Ft, which will become, Fc will be Fs cos beta minus alpha divided by cos phi plus beta minus alpha, and Ft will become Fs sin beta minus alpha divided by cos phi plus beta minus alpha. So, these are the 6 forces which act during the cutting operation. Okay. Now, we can rearrange them also. This is the value of Fs. Fs is tau b into T1 by sin phi. We have discussed it in the previous slide. Okay. So, these are the forces. We can write down the equations in term of this. If we will put the value of Fs, okay, Fs in terms of this, then we can find out the new value for Fc or Ft. Now, we know that the merchant determined phi assuming the minimum energy principle in metal cutting, so that the deformation process adjusted itself to a minimum energy conditions. So, for this equation what we have to do, we will differentiate cutting force with respect to phi and equate it equal to 0. Okay? Or we can write down it tau into b into T1 divided by it will become sin square phi cos beta minus alpha, and this will become cos 2 phi plus beta minus alpha. This is cos square, this will become phi plus beta minus alpha. This is the value which comes out by putting the value of Fs in terms of tau and beta. Okay. So, if we will differentiate it and equate it equal to 0, then what we will get, we can write down it cos 2 phi plus beta minus alpha is equal to 0, or we will simplify it as 2 phi plus beta minus alpha is equal to pi by 2. This equation is very important equation, and this equation is known as merchant first equation. okay, or we can write down it as phi is equal to pi by 4 minus half beta minus alpha, okay, और एफ सी को हम लिख सकते 2 इंटू बीटा 1 इंटू में कॉट फाई, these two more formulas are also there, and एफ टी we can write down tau into b into t1 into cot square phi minus 1. So, these are the formula which we can use when we are solving the numericals based on the merchant circle. So, this equation is very important equation from the exam point of view. So, this is all about the merchant circle. So, thank you very much for listening the lecture.